Already January 2023 Unit 5 Section A part is already uploaded. Now, today in this video, I'm discussing Section B questions, the descriptive type questions. So we'll straight away move to the first question of Section B. Question number 11. Water in a swimming pool at the Olympic Games should be at a temperature of 28.0 degrees Celsius. A pool contains 2750 meter cube of water at 16.5 degrees Celsius. Calculate the increase in internal energy. Of the water when it is heated to 28.0 degrees Celsius. The density of water 998 kilogram per meter cube. Specific heat capacity of water is 4190. Anyway, they are asking about increase in the internal energy. Since it is energy, obviously internal energy we can equate to mc delta theta. Correct? So see the units. The specific heat capacity is given in joule per kilogram per Kelvin and density is 998. So from this, since the density is known and the volume is also known, from this we can calculate the value of mass. The density rho is mass by volume. Therefore, mass is equal to density times volume, correct? The density, make sure and keep an eye on all the units. So density is 998 multiplied by the volume is 2750. So if you are multiplying, so what we will get? We will get the mass 2.74 times 10 to the power of 6 kilogram. This is the mass. And then they are asking for the increase in the internal energy due to this increase in temperature. We know that internal energy increase is mc delta theta. So what is delta theta? That is the final temperature minus initial temperature. And the specific heat capacity is given per increase of Kelvin. So 28.0 degree, if you're converting into Kelvin, it's not necessary to convert both into Kelvin. Why? Because we are actually taking the difference. Because 28.0 plus 273 is the respective value of Kelvin of final temperature. That means 28 plus 273, that is 301. And 16.5 plus 273, that is 289.5. Even if we are adding 273, the difference remains same. So what is the difference? You all keep that in your mind. Okay. So if we are not even adding this conversion of this Kelvin, you will get the same change in temperature. Okay. Here in this question. So that means 28 minus 16.5. So what is that change? 28 minus 16.5. So that is 11.5. So 11.5 Kelvin. 11.5 Kelvin. 11.5 Kelvin. So substitute it. That is 2.74 into 10 to the power of 6. The C value is specific heat capacity. That is 4190 multiplied by delta theta. That is 11.5. So if you are plugging all these values, we will get it as 1.32 times 10 to the power of 11 joule. So what is the increase in the internal energy? 1.32 times 10 to the power of 11 joule is our answer. See, for getting 3 marks, if you are calculating the density, you will get For calculating the mass from the density, you will get 1 mark. For getting 1 mark, we should show the change in the temperature. That will give you 1 mark. If you are plugging in the right formula and you are getting the right value, you will get 1 mark. So 1 plus 1 plus 1. That is 3 marks. Clear? Okay. Move to next question. I mean, the B part of this question. What is this B part? A heater is used to increase the temperature of the water. State why the amount of energy supplied by the heater will be different from the value of delta E calculated in A. It's a 1 mark question. So some kind of theory we should apply here. So here you can see that while transferring this energy is actually transferred from the water to the surroundings. Some energy is actually lost to surroundings. So as a result, what happens? Whatever be the energy supplied by the heater, it is not completely converted to internal energy. So actually, energy is losing. That is not a right word. So what we should do? What we should mention? We should mention that some amount of energy from the water is transferred to surroundings. So that is very important. So we'll write that statement over here. So what we will write? Energy is transferred. Energy is transferred from the water to the surroundings. So what happens? As a result, not all energy is used. Energy is used to raise the temperature. Got it? So that is very important. So that is the answer for this question. Hope you got the idea about this part. So don't, in this kind of questions, don't mention what? Don't mention energy is lost. Energy is not losing, because according to conservation of energy is neither created nor be destroyed. You can mention like this: energy is lost to surrounding. That is okay. But simply energy is lost is not actually a valid statement. Okay. Fine. So that's about this question number 11.